My name is Adam Usman, and the topic I'm presenting today is actually the effectiveness implementation of secure software development lifecycle. So, first of all, before getting into the concept of secure SDLC, I want to actually highlight us or brief us on what SDLC is and the traditional model of the SDLC and how um, it leaves a security gap unpatched actually. So first, SDLC is actually a process, or the software development lifecycle is actually a process whereby an application or software um, uh, is actually a process followed before using when an application is built from actually the planning stage or phase to actually design phase, building, testing, and as well down to where that software is deployed and maintained. So in the traditional model of SDLC, security test is actually performed only at the testing phase of software development life cycle. So this test is accompanied with other tests, which is like the functional test of that application. Then also um, security test is also conducted. So at that point, really, it's a bit cumbersome to cover all the patches or the flaws that has been made from the initial or the right from the inception of that software development lifecycle, which is the planning phase. So companies actually consider security as a process of quality assurance when application is fully developed. So till when an application is fully developed, that is when security is being actually that application is being actually tested for security. So without too much ado, let's get into this concept of secure SDLC and see how actually it provide security and as well to software and and the company as a whole, and as well fix the gaps or the lapses in the traditional model. First of all, Hiritil, who am I? By day, I'm a cyber offense specialist at Essentry Systems Limited, and by night, I'm a security research expert at Cyber Safe Foundation, and I hack all the things. Without so much, I guess I'm a cyber nerd and I do everything cyber. So cyber is basically my hobby. Yeah. So I first of all on this slide introduction. So a secure software development life cycle, or SDLC actually is a process or a model which adds security at every stage of the development a development stage, right from the planning, design to development, deployment, and beyond. So it's just like in the real world, you have a vehicle and you actually uh, uh, taking it for servicing before it actually breaks down. So you can look at it that way in a real world sense, but it's not a word for word, relational. But you can actually relate to the concept or the idea I'm actually trying to pitch there. So the goals of secure SDLC. One is secure coding practices. So for the developers, actually, uh, most developers actually build code or application without actually security in mind. So using this approach, it ensures that developers adhere to security coding practices to prevent against building insecure applications, whereby the developers are going to be aware of techniques like input validation, using some dangerous functions in programming languages, and other stuffs. Yeah, so and then the second goal is actually to protect data. So end user, company, and customer data is protected and not disclosed to unauthorized entities. So when this concept or model is actually practiced, uh, data sensitive information are actually being protected against unauthorized entities. So from my own experience of actually penetration test or security consultancy, sensitive information disclosure is really one of the main or one of the critical, things found on near every applications. So developers just most times dump sensitive information like tokens, API keys, production credentials, or database credentials on public repositories without actually privating them. And so public repositories like GitHub and so on. Yeah, so using this model, actually this vulnerabilities or this uh, patch this security flaw is actually being patched. Then a risk assessment, whereby it's reducing the risk of breach and attack through vulnerability tests, verification tests, and proactive security operations. So when you are using this model, modular or unit tests are actually performed at each phase of the software development life cycle. Security tests as well, of course, yeah, and at the testing phase or verification phase of the SDLC, a black box test or penetration test of that software is performed from an external or a end users malicious end users perspective. So yeah, so these are the goals of secure SDLC. Yeah, so moving to the features of SDLC. So it facilitates the integration of development and or with security. So secure implementation of this application actually facilitates security, and it's actually um makes security a available in every piece or every step in that development in that implementation of that software. So you have at every piece software security actually implemented or integrated in the development process. Then it elevates the organization's understanding of its current risk exposure. So yeah, at the planning stage, or which is the first phase of the software development life cycle, you actually have some grounding rules or governing some policy governing uh, the features actually uh, taken from the stakeholders or managers of that application or software to be built. So right from the initial stage, you have a security policy being implemented, which actually elevates the awareness of, okay, this risk exposures or threat, you know, attack surface of the application or software to be built actually. Yeah. So the third point here is build security in software as it is designed. So while this at the design phase, when the functional requirements of that application it's been uh enlisted, you have a backup security or a secure design process backing up that functional requirement to actually make sure they are actually implemented securely. And then it also enables software developers and IT security to work closely together. So you have the developers actually working closely together with IT security to build a secure application. So the developer actually have security in mind as they are building the application, not just, thinking about, okay, how they would push code that could cause serious, uh, negative impact on that could cause possible negative impact on the on the application and the company, of course. So think about a developer actually pushing code that actually doesn't sanitize input from users, and then a user can just simply inject a malicious code into the database and extract all sensitive information in that application database, also known as SQL injection or injection type attacks. Yes. So now moving on to the project life cycle for SSDLC. So for in the traditional model, we have uh, a layer of 6 or 7 phases of the development of the project life cycle, which is planning, requirement definition, designing, building, testing, and then deployment and maintenance. So as I said earlier, in the traditional model, security test is only assessed at the testing phase, which is the phase where the application has already been built, and then the functional features of that application is actually being tested for QA or quality assurance. So, and then you have security tests conducted or performed at that stage. So yeah, so for SSDLC, we have actually a uh a uh, a list of 5 phases that actually add security to this traditionally used 7 phases. So at the very initial stage, which is of the traditional model, which is actually planning, we have governance or security governance and policy. So this security governance is actually a policy that a grounded rule that is prepared to build a process and training plan when new features are collected from various stakeholders. So from the inception or while at the drawing board, when the application, the features are collected from various stakeholders on what the application would do, what is it for, and so on. You have a backup backup security policy that would actually be in place for each and every feature that is actually listed by these stakeholders. So a sample functional requirement is okay, a user needs the ability to verify their contact information before they are able to renew their membership. So that is a functional requirement. So, and then a sample security consideration is users should be able to see only their contact information and no one else's. So this actually is a flaw, also a major flaw in, or if you like, is actually even the number one on the OWASP top 10 API vulnerability for APIs or application programming interfaces. So, which is also known as BOLA, or broken object level authorization, whereby a user A actually looks at information or
Adamu,
data of.
please
Yes, sir.
be far, because our time is fast approaching. So I want you to enjoy
Okay.
your time. Thank you.
Okay, I should be sorry. I should be what? Sorry.
More be fast, so that at least our time, because we are closing here by 1 o'clock. So, and time
Okay,
is a
okay,
fast
okay.
approach.
Yeah, so
Thank you.
okay, sure. So that's it. So you have this is it for the governance, and then the second phase is actually design, secure design. So when functional so at the design phase, that's where the functional requirements are actually being listed. So these functional requirements typically describe what should happen, while security usually focus on what shouldn't. So if you have a sample function, like, okay, page should retrieve the username, email, phone, and address from database and display on the user interface or screen, then a sample security concern will be, we must verify that a user has the valid session token, or they really prove their who they say they are, or their identity, before they get that information, so that there shouldn't be a cross feature whereby another user would actually retrieve information that is not theirs actually. So yeah, so and then the third on the project life cycle for SDLC is actually secure implementation. So during development, security is implemented to make sure dependencies and components used to build applications are secure and are well, and as well a secured coding practice is exhibited. So at this phase, these checks are performed: static analysis, security testing. So using SaaS tools or the code, like, okay, for example, sneak, you can actually push in your code, and then it would actually perform a static or a SAST analysis of that code to look for um, uh, uh, bad coding practice used by the developer. And then second, you have software composition analysis. Is actually a step of actually using tools to actually, or going through the applications to gather open source dependencies and application composition used to build that to develop that application or software. So that is important to know, okay, to keep track of, okay, open source tools used, so when they are actually obsolete, you update them, or when there is a 0-day vulnerability, they actually get patched or fixed. Then we have updating, patching, and upgrading software component and dependencies, all at the secure implementation phase, which actually is performed at the building at the building stage of the software development life cycle. So next is actually verification. So the verification phase is where applications go through a thorough testing cycle to ensure they meet original designs and requirement. So vulnerability assessment and penetration test using manual and automated method are actually conducted. And as well, this phase includes automated tools like CI/CD pipelines, whereby, okay, before a code is actually being merged or deployed or pushed to a code base, it is actually assessed for security, like, okay, making sure that the code actually has no dangerous functions used, like, okay, the eval or some of the dangerous, functions used in programming languages like PHP and so on. So this verification test include penetration test, automated execution of application units that verify the correctness of on the underlying application, which is actually a functional test of that application to test for, okay, these automated tools don't really know, okay, the business logic or the functional logic behind your application. So manual penetration test, and also, are conducted to actually, or manual assessment is actually conducted to actually verify the, that security flaws are not there, or business logic flaws are not actually do not really exist. So automated deployment tools that dynamically swap in application secret to be used in a production environment. So for some applications actually have, or hard code, or developers actually hard code sensitive secrets in applications like API keys or tokens. So these hard coded secrets are actually swapped or replaced with a variable that is just referenced. So even if a malicious and unauthorized entity have access to that code base, they just see a a a placeholder there, not really the actual token or the keys actually for that application. So, and then last on the project lifecycle for SDLC is actually maintenance and evolution. So even after that, after performing extreme thorough testing process, newly published vulnerabilities may impact applications that have been pushed into production. So 0 days is actually a term whereby a new vulnerability is actually being discovered in applications, application dependencies that used, okay, like jQuery or you know programming language versions and so on. So, and as well, additionally, an application may have different may behave differently in runtime in production environment than it does in its static state or in development environment. So dynamic analysis of that application is actually conducted, and as well, at this stage you have some proactive security tools being implemented, like, okay, load balancers, web application, if it's a web application firewall or firewalls and so on, to and then EDRs, endpoint detection and response tools, actually to monitor traffic and for malicious behaviors of users and so on. So lastly, here we have the benefit of SDLC. So it enhances the reliability of delivery timescales, reducing costly details. So this practice of SSDLC actually saves so much cost because you have security at each stage. So the risks of first, the risks of security breach is actually reduced, and the cost of actually breach, or the cost of security test after deployment, is actually reduced. So, and then it reinforces confidence in product and services, including that of stakeholders, because you have the stakeholders and everyone aware of security right from the first stage. So there's that confidence in security and all, and it changes the perception of security as a product feature. So uh yeah, so, and then highlight that security is not solely associated with compliance measures. So on most companies or startups actually just perform security or security tests for compliance, measures, PCI, DSS, and so on, or whereby they have to meet, with certain standards of, compliance standard and so on. So, or using this approach, you have just security, not just for that, but for the overall protection of companies' data assets, and preventing it from actually defacement and all. Then you have increase in collaboration between security and development teams. So uh, yeah, whereby the you have the security team and the development team actually working together from the design phase down to when the application is actually being actually deployed. Yeah, so that's it for my presentation. So thank you.